Assalamualaikum warahmatullahi wabarakatuh to our students. So now let's continue the third part of the chapter, that is forward bias and the IV characteristic. Okay, so what is forward bias? So just now you learned about reverse bias, right? So now let's draw the forward bias. So you have P type and then you have N type here. And then what you will be connected at the external supply. So here become, instead of negative, here become plus, minus, plus, minus. So let's explain here. P-type, majority carrier, whole or electron? Whole. N-type, majority carrier is electron. So whole is the positive charge, here is positive charge. So positive will be repel or attract. So positive and positive will be what we call repel. So how you explain this one? Number one, P-type connected to the positive supply. Number two, N-type connected to negative supply. And number three, positive and positive, the whole and the positive supply will be repel. So what happens when it is repel? So instead, here is moving towards here. So you go towards your depletion. So this one will be moved inside. So let's try to redraw back. So your hole here will start to move towards here. Okay. You have small depletion here. For your N-type, this is negatively charged. Instead of here, it will start to move here. So you will have a lot of electron at the junction. So now what will happen to your depletion region? So at first, your depletion region, number 4, depletion region will be smaller, right? Will be smaller because the electron and hole will be repelled from each other. So when the depletion region becomes smaller, can the hole easily move towards the end? Yes, so you can get some current. So at your forward bias, you will have the current. So as we can see here, this is a forward bias. So you apply here positive. So you apply here. Here is positive and here is negative. Okay. So what will happen? The hole here will be repelled and move towards inside. The electron here will be repelled and move towards inside. Then the depletion region become smaller. So in this explanation, we're talking about in terms of electric field. So your electric field will be much more lower, and that's why you can have the current. Okay. So let's see this formula. So for your forward bias, you will have some current. So how we calculate the current? So this is the formula. ID equal ISE VD and VT minus 1. So VT here is what we call thermal voltage, the same like before. IS is the reverse bias saturation current, so the value here will be very small. And N is the emission coefficient, and it is usually 1. So why we call this one diode? Because whatever you learned previously, PN junction, so this is what actually inside your diode. Okay. Okay, so this will be the first example. So how are you going to calculate the current inside the PN junction? So given this question, T equal to 300, your reverse bias saturation current is here and N equal 1. What you need to calculate at plus 0.7 and minus 0.7. So what does it mean by VD here is, this is your PN junction. What will be the voltage that you apply at this external source? If it is plus, so this means forward or reverse. So this means forward bias. If it is minus, this means reverse bias. So you are going to expect when your VD is equal to 0.7, you will get some current. But when your VD is equal to minus 0.7, it is reverse bias, right? So your current will be almost 0. So this is forward bias. This is reverse bias. So what you need to do now, you just plug in the formula. This is the reverse bias saturation current. This is an exponent. This is your VD, thermal voltage. Why your VT is 0.026 here? Because it is at room temperature. And then when you calculate, your current is you can get some current here. 4 forward bias, 4.93. If you replace at the reverse bias, minus 0.7, your current here is negative and it is very small, so it is approaching 0 ampere. So you cannot get any current at the reverse bias. So please try to spend some time to solve this question and let me know if you have any problem. Okay, so let's jump to the last part of this chapter. So what we are going to learn now is the current and voltage characteristic of the diode. So what is actually IV characteristic here? So if you recall back your resistor, so this is IR, this is VR. What is resistor? Resistor will not allow will block some current, right? So you have this is the R. So what is the resistance? Is the I will be proportional to V. As the current increase, the voltage will also be increased and vice versa. That's why you have the R. So this is what we call IV characteristic of a resistor. Now you know that your PN junction is actually your diode. What is the function diode? What is the function of diode? To allow current to flow in one direction. Okay, one direction. Okay, so now we want to observe what will be the IV for your diode. So this one IR, DR, so this is diode, ID and VD. So you know at your diode, you have two conditions. One is forward bias, one is reverse bias. Which one you will have current? For forward bias, right? This one I equals 0, this one you have some current. So how we can know that what is the minimum volume where it will go to the forward bias? So remember the term VBI, the built-in voltage. So what is a built-in voltage? Is the minimum energy required to pass the barrier. So let's say now we apply here, let's say forward bias, plus minus, right? Your VBI, your turn on voltage here is 0.7 for this diode. So if I apply here 0.5, means I start to apply here 0.5. Do you think this will be turned on? This is we can call is like turn on voltage. No, because it is less than your VBI. So your current here will still be 0. If I increase to 0.75 volt, do you think the current can flow easily? Yes, because it already passed the turn on voltage. So at here 0.7 volt, there will be some current. So this is what we call forward bias. Now what will happen to the reverse bias? So here you apply reverse bias. So it become PN minus plus minus plus. There will be no current, right? Because the depletion will be widened. So how is your IV characteristic here? So this area will be no current. So this is reverse bias. Here it will be forward bias. Here will be your VBI. So this is what we call IV characteristic of a diode. Okay, so as the explanation goes just now. So this is your VBI. This is your forward bias. This is your reverse bias. So how you can denote PN junction to the diode? So this is your diode. Here is your VD. Here we need to be plus, minus, and this will be your diode current. Okay, so this is a non-linear characteristic because you have a off current here and there is some current after the VBI. So we call this one non-linear. For your resistor is a linear characteristic. Okay. Okay, now let's see what will be the effect of the temperature on the IV characteristic. So as the temperature increase, you are going to increase what we call thermal energy. If you recall the first chapter, the first part of the semiconductor, as we increase the thermal energy, okay, so as we increase the temperature, the thermal energy also will be increased, right? So the covalent bond will when the thermal energy increase, it will easily to break the covalent bond, right? So when it is easily to break the covalent bond, we can get the current easily. So if you see here, T0, T2, let's say this is 300K, and your T0, sorry, we increase the temperature, right? So let's say this is 500K, T0 is 300K. So what will happen to your IV characteristic? Let's say the blue one here, this one is at room temperature. Okay, so as you increase the temperature, your VBI will be much more lower. Why? Your turn on voltage. Imagine this one is like your turn on voltage. Why it is become lower? Because you have the extra energy provided inside the PN junction. So you just need a very small, let's say here is 0.7. As you increase the temperature, you only need, let's say, 0.5 volt in order for your diode to turn on. So we can call this what is turn on voltage. So as if you keep increasing your temperature, so your IV will be much more in front. So maybe here is 0.33 volt. So that's the relation how the temperature will be effect on the IV characteristic. Okay, so that's all for the long theory chapter. Finally, we have done for the theory chapter. So the keyword that you learn for this chapter, first one is drift current by apply electric field, diffusion by low and high concentration, how we can build PN junction. We have three keywords here. One is diffusion. So how we can build PN junction, can we recall? The first one is what we call diffusion. Second one is recombination. The third one is depletion. So hold with these three keywords. What happened during forward bias? Do you have current? Yes. Reverse bias, no current. Junction capacitance relate to what? Relate to reverse bias. Diode current relate to forward bias. What is the IV? Is it linear? No, because you have built-in potential. What is built-in potential? Is the minimum energy required to allow the current to flow, right? To overcome the barrier. What does that mean by barrier? Is depletion. And what is depletion? Depleted of carrier. Okay. So this is the summary. So please try to understand all the keywords. So if you have any questions,